Okay, this is 9.2b cones. So we're going to take some of the information that we learned with pyramids and apply them here, but with cones. So let's think about a minute. Why don't you take your notes out and see if you can figure out what the lateral area, surface area, and volume are for right prisms, cylinders, and regular pyramids. And then check back to make sure that you have all the formulas right. Okay, so we have our lateral area and surface area and volume for a prism. Finding the perimeter multiplied by the height is how we find the lateral area. With the surface area, we're going to add on the areas of those two bases. And then the volume is just the area of the base as tall as it is. And that's the same thing for both a prism and a cylinder. It just changes whatever that B is. So for a cylinder, we know that we take the circumference and multiply by the height to get the lateral area. And with the surface area, we take that and add in those two circle bases. And then the volume is pi r squared h. So just the area of the base multiplied by the height. Think of it almost like stacking CDs or something on top of one another. Pyramids, 1/2 the slant height, remember L is slant height, times the perimeter. Our total surface area is the lateral area plus one base. Remember, we only have one of them when it comes to a pyramid. And then our volume is 1/3 the area of the base times the height. Okay, so let's go ahead and match up some of these things. So we have some words. So we have altitude, vertex, axis of the cone, and slant height. So the segment that joins the vertex to the center of the circular base, that's going to be the axis of the cone, goes here. So I'll box those so we know that those go together. Any line segment that joins a vertex to a point on a circle, that's going to be our slant height. So I'll circle those in blue so we know that those are related. And then a perpendicular segment from the vertex to the center of the base. And that's going to be our altitude. So I'll bubble those so you know that those go together. And then you know what the vertex is. The vertex is just the point where all of those slant heights meet, so to speak. The point of the cone is going to be our vertex. Now it's important to note here that there will only be a slant height when there is a right circular cone. So a right circular cone is like this one with that the altitude and the base make a right angle. So a waffle cone or anything like that. Anytime that it's going to be slanted is going to be a different case. Okay, so how did we find the lateral area of a pyramid, of a regular pyramid? Well, we used our formula for lateral area being 1/2 times the slant height times the perimeter. So the lateral area of a cone is very similar, but instead of using perimeter, we're using circumference. So we can go ahead and plug that in. So 1/2 the slant heights times the circumference, but we know what circumference is, so let's write that in. So 1/2 the slant height times 2 pi r. So if I go ahead and get that, so I get my lateral area to be, now I see that the 1/2 and the 2 cancel, so I end up with just pi r times my slant height, and that's what you're going to find right down here. Okay, what about our total surface area? Let's think about a right circular cone. So if I have my circle at the bottom and this is my slant height coming down, and it makes a right angle down there at the bottom. I know that my surface area is going to be my lateral area because I have to go all the way around, as well as I just have one base. So it's just like a pyramid in that we only have one base here. So by plugging everything in, I can see that I know my lateral area is pi r L, and then my base is just the area of a circle, so pi r squared. So again, that's what you're going to see right down there. Okay, so let's practice some. So if I have a right circular cone where my radius is 3 and my height is 6, I need to exact an approximate lateral area L and then the exact and approximate total area for my surface area. Now it's very important that we recognize the difference between exact and approximate. A lot of us have been misunderstanding those words. So exact will have no decimals, it'll have radicals, it'll have all that stuff. And approximate is where we're going to round. So let's start off with the first one. So exact and approximate. So I know that my lateral area formula, so sometimes I like to write that down just so I can keep track. So I know my lateral area is pi r L. Now I need to find L, I'm not given that. So we have to do the Pythagorean theorem with this triangle. I know this is 6, I know this is 3, and then this is what I need to find. So 3 squared plus 6 squared equals L squared. 9 plus 36 equals L squared. So that gives me 45. And so I get that L is equal to 3 root 5. So that's perfect. So let's go ahead and plug in what we know. Pi times my radius, which is 3, times my slant height, which is 3 root 5. When we multiply, we only multiply the 3's together because that root 5 is already being multiplied. So I end up getting my lateral area as 9 root 5 times pi. Don't forget your units, centimeters squared. So when I want to have my approximate, I plug that into my calculator because now I'm ready, and I see that my lateral area ends up being 63.223 centimeters squared. So that's going to be for the lateral area. Now, for the surface area, it's a little different. Now, we know that we're going to take the lateral area, but we have to add on that base. So that's good. We already have the lateral area done for us. So when I want my exact lateral or surface area, I use my exact lateral area. So that's 9 root 5 pi plus the base. And the area of my base is pi r squared. So pi times 3 squared. So I end up getting, for my surface area, my exact surface area being 9 root 5 pi plus 9 pi. And I can't combine those because I have a root 5 in one, and I don't have one in the other. So let's make that look a little bit different so you don't get confused. Okay, so that's going to be it in terms of our exact. Now, in our approximate, we just plug all that into the calculator together. So 9 root 5 times pi plus 9 times pi, and we end up getting 91.498 centimeters squared. So those are your two answers. This is just breaking it down for us to explain that we need to use the Pythagorean theorem in order for us to find the slant height. And remember, we can only use a slant height if we have a right circular cone. There is no slant height the second that it becomes oblique. So a good thing to recognize is that it has to be right. So that altitude here has to be perpendicular to this circular base here. So you see that right angle that's formed. All right, volume of a cone, pretty straightforward, very much like a pyramid, except it just has a circular base. So seeing the area of the base and the height down here times 1/3 is something that we've already seen before in terms of pyramids. Okay, so looking at the comparison between a pyramid and a cone, we know that this is our lateral area here for a cone, but remember we wrote that a little different. So if you want to rewrite that as lateral area, we know that we had 1/2 L times 2 pi r for our circumference. Those canceled out, and so you ended up with pi r L for your lateral area. Either one you can use. So you might want to take a look at this and just recognize the similarities between pyramids and cones. You just have to recognize that your bases are going to be different. So you could have for a pyramid a pentagon or an octagon, whereas a cone will always be a circle. Okay, so find the length of the slant height L of a right circular cone with a radius of 5.2 feet and a height of 3.9 feet, and then find the total area and volume of that cone. So what I always do is I draw a picture. It doesn't have to be perfect, but you want to draw a picture. So I know that this is L automatically, and I know that my radius is 5.2, and I know that my height is 3.9. And I want to find the area and volume. Now we know what's important here is that we have to find L. L is very important for lateral height, for lateral area, and we need that for surface area too. So what we do is we set up the Pythagorean theorem. I have a triangle here. I have L, 3.9, and 5.2. So when we plug that in, take a minute, figure out what your slant height is. Okay, so you should have gotten 6.5 feet for your slant height. Now take a moment and see if you can figure out what your surface area and your volume are, and then come back and check in. So you should have gotten that your surface area was 191.134 feet squared. So we used our formula and then we plugged in what we knew and then we ended up with that. So for our volume, it's very similar. So if you haven't done that already, go ahead and do that. So what you should recognize here is that we're finding 1/3 of the area of the base, which is a circle, times the height. So slant height is not used for volume. And then at the end, you should get 110.433 feet cubed. Now, it's okay that our volume is smaller than our surface area. That's fine. The surface area is going all the way on the outside and covering the bottom, whereas the volume is just what it can contain on the inside. Okay, find the height h of a right circular cone in which the diameter of the base measures 9.6 meters and the slant height is 5.2. So again, I draw myself a picture. Doesn't have to be perfect, but the picture helps me solve it. I'm told that my slant height is 5.2 and I'm told my diameter. Now this is important. I need my radius. So the radius is when we cut the diameter in half, and so I get 4.8 as my radius. It's very important that you recognize that you have to cut it in half. And I don't know my height, but what did I just make? Now we know it's a right circular cone, so again we can use our slant height. All I have to do is use the Pythagorean theorem. I'm told that that's 5.2, this is 4.8, and that's h. So take a moment and see if you can come up with the right answer. You should have gotten something like h equals 2 meters. And I did that by just using the Pythagorean theorem and then solving for h.